Welcome to your wind video part 1. We've already talked about winds a little bit with your sea breeze and land breeze and also starting our heat absorption lab today. So hopefully you can kind of get the gist of this. It's not too hard to kind of comprehend. So make sure you have your notes in front of you. It has the pressure visual organizer to the left, and all you're doing is filling out the right hand part on the back of your air composition notes. So make sure you have that. All right, did you know that Alaska is the windiest state? Yes, it is. A lot of people think that Chicago is a windy city. It is very windy there, but Alaska is actually the windiest state, if windiest is a word. And during May 1999 tornado in Oklahoma, researchers clocked the wind at 318 miles per hour, which was the highest recorded. So why does air move? Well, wind is the horizontal movement of air. It goes from high pressure to low pressure. And we will actually look at a convection box later on this week where you can actually see wind actually making its movement through the box. So make sure at the top of your notes you have high and also low. So it goes from high to low. This is caused by unequal heating, and it also creates unequal air pressure, which we know happens from land breezes and sea breezes and things like that. The greater the pressure / temperature, the faster the wind moves. So if it's going from really cold areas to really hot areas, then your wind is going to move a lot quicker than it would if it's just kind of like a cool area to a warm area. Winds are actually named from the direction that they come from. So that is very important to keep in mind when we start naming these winds on your notes in the middle of your page. So they are named from the direction that they come from. Quick question first. Would there be winds if the Earth's surface were the same temperature elsewhere? Make sure you explain that on the bottom of your sheet. Would there be winds if the Earth's surface were the same temperature everywhere? Okay, obviously the answer is no. But you need to put that on the bottom of your notes because that's not on your notes, so you need to put it at the bottom. Thank you. Okay, measuring winds. We can measure it with an anemometer, which is this thing up here. You have a picture of it on your notes. That measures wind speed. So the quicker that it moves around, the quicker the wind speed is. And also a wind vane, and you might see these on top of houses or things like that. And this tells us the wind direction. It's not as accurate with speed, but it is pretty good with wind direction. And a wind vane is just for wind direction, which is this actually in the middle. Alrighty. We are not going to use that. And the equator receives more direct sunlight, so there's a lot of low pressure there, which moves towards the cold poles. So we're going to see this on our little half globe in a second. And the poles received a lot less direct sunlight, so there's a lot of high pressure there, which moves, which creates the air to move towards the equator. And then the cells are every 30 degrees latitude. So you've got all this low pressure down here and all this high pressure up here because it's colder up here and warmer near the equator. Okay, low pressure is high heat. High pressure is low heat. So again, it's like opposite day. Okay. All right, so here are your global winds. You might want to pause it here because you need to make sure that you have it down. Up here is the polar easterlies. So in that 60 degrees, you have like a 60-degree latitude right here. Above it, you need to put polar easterlies in the direction of these arrows going to the left because they start in the east and go towards the west. The westerlies are next, and these are actually the prevailing westerlies, and this is between 60 degrees north and 30 degrees north. And then in the middle are your trade winds, which kind of come together towards the equator. And then right underneath it, doesn't have it right here, is the doldrums, D-O-L-D-R-U-M-S. And that is where there's really no winds there. Alrighty, let's see. Oh, okay, so we're not going to actually do a lot more with that. Let me see if this will pull up. It won't. Okay, now it will. I got it up. Okay, so we also have some local winds. This is due to local geographic features like the shorelines, mountains, and near examples are sea breeze and land breezes, which we already went over. This is due to day and night heating. Mountain and valley breezes are due to differences in temperature and elevation. So the sea breeze is up at the top because it starts in the sea. Remember, winds are named from where they start. So a sea breeze starts in the sea and it goes towards the land because it is hotter on the land during the day. And then at night, it actually goes the opposite. So at night is a land breeze because it's colder here and it's warmer on top of the water. So at nighttime, all of the water, or I'm sorry, all the air is moving towards the water. And during the day, it would be nice to sit on the beach because all the air is moving towards you. So you get a nice breeze. Okay, so this is just another thing to look at as well. You've got all the low warm air coming over here because it's hot over here and it's cool over here. This is during the day. And at night, it does the opposite. So all the warm water is still there because it kind of absorbs the heat a little bit more. And then the land lets go of that heat a lot quicker, so it's cool at night, and then it moves in the opposite direction. And we're not going to look at the animation. We're not going to do that either. And you can take a look at these questions if you want to, because we will be having a quiz later on this week before break. And oh, I have more questions. La 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 la. And yeah, you'll be doing your performance task later, so don't worry about that. Okay, make sure that you have your notes done and you should be good to go. Have a great evening.